Hey everybody, we're looking at the last section of our topic 12 notes right now, and we're going to start off with this theorem where you need to fill in those highlighted words. Okay, fill in the blanks for those highlighted words right there. This first theorem tells us that the measure of an angle formed by two lines intersecting inside a circle is half the sum of the measures of the intercepted arcs. Okay, so this is talking about when you have two secant lines that cross through a circle and meet each other in the middle of that circle. Okay, um, so first of all, in this diagram, you can see it. Line AB and line DC are both secant lines. Okay, they cross through and they both meet that circle at two different spots. Okay, line DC meets at D and C. Line AB meets the circle at A and B. So they're both secant lines, and they cross each other. And what it does for us is it creates a bunch of angles down here inside of the circle. Okay, we've got angle one is the one that we're going to find here in just a second. We're going to talk about angle two also. Okay, so what that diagram also shows us is angle one's intercepted arc. Okay, angle one has an arc affiliated with it. This arc right here, AC, arc AC, matches up and is intercepted by angle one. Now, what we also notice in this diagram is straight across from angle one, across the other side, we have a vertical angle. Okay, and we know from way on back when we discussed it in the first semester that vertical angles are congruent. So angle one right here and the one across from it on this side are congruent to each other. But what that means is that since those angles are vertical angles, we also are going to be dealing with this arc. Okay, because we have two of those vertical angles right there, both of those intercepted arcs, you notice there's an S on the end of this arcs right here. Okay, the reason that's there is because we are going to be dealing with both of those arc measurements. Okay, now this theorem tells us that if we're trying to find the measurement of angle one, what we can do is we can take the sum of those two arcs, this 80-degree arc and this 40-degree arc. We take the sum of that, so we add them together, and then we cut it in half. Okay, this is telling us that the measure of our angle over here is the sum of the two intercepted arcs divided by two. So it's going to be 80 plus 40 divided by 2. Doing a little quick simplification, it turns out that angle 1 is 60 degrees. Okay, angle 1 turns out to be 60 degrees over here. Okay, so I said we were going to talk about angle 2. Let's think about it for a second. Okay, when we look at angle 1 and angle 2, I'll use a different color for angle 2 over here. You can see that angle 1 and angle 2 are right next to each other, and they form a straight line. They form this line that goes straight across right there, right? So what that means is that if we added together angle 1 and angle 2, it should be 180 degrees. Okay? So a little quick math, a little quick subtraction tells us that angle 2 must be 120 degrees. Okay? Don't forget about that as you work on your problems today. That is something that might could come up. All right, let's go on to our next theorem. Our next theorem, go ahead and fill in those highlighted words there. It says that the measure of an angle formed by two lines that intersect outside a circle is half the difference the measures of the intercepted arcs. Okay, so as you read that sentence, it is a long and complicated sentence, but it's actually very similar to the one that we just had on the previous slide. Okay, this one right here is saying that when you so on the previous one, we had angles on the inside of a circle, and the measure of that angle was half of the sum of the arcs. On this one, our angle that's created is outside of the circle down here. Okay, and if the angle is outside of the circle, then instead of taking half of the sum, we're going to take half of the difference. So instead of adding together our two arc measures, we're going to subtract arc CE minus arc BD, divided by 2. Arc DC minus arc BC divided by 2. Arc BDC minus arc BC, okay? So this can be done with secant lines, tangent lines, or a combination of those two things, okay? All we're concerned about is finding the difference and dividing by 2. That's what's going on here. Find the difference, cut it in half, okay? Also, take note of this. Right here and here, on all of these fractions, we've got some vertical absolute value bars, okay? Think about this. What would happen if you subtracted your arc lengths and ended up with a negative number? Okay? If you ended up with a negative number, you would have a negative angle. Now, how does that make any sense? So you're going to have a negative 20-degree angle being made between two lines that intersect each other. That doesn't make any sense, does it? Okay? That is what the purpose of those absolute value bars that I just highlighted in pink are. Okay? Those absolute value bars are what makes absolutely sure that our answer ends up being a positive number. All right? Go on and look at this example. This example tells us that arc BC over here, arc BC, I'll mark it in purple, is 15. That is a 15-degree arc. Arc DE is a 35-degree arc. So we'll go ahead and mark both of those things. We are looking to answer two questions. First question is, what is the measure of angle A? So that's this angle right out here. And our second question is, what is the measure of angle BFC? So that's this orange angle right there. Okay? So our first one, angle A is on the outside of that circle. And according to the theorem that we just filled out, the angle on the outside of the circle is half the difference of the measures of those arcs. So if we take the difference of those arcs and cut it in half, that's what we're going to try and do. We're going to do the difference, DE minus BC, and cut it in half. That's 35 minus 15. 35 minus 15, that's 20 for you math majors. So when we cut 20 in half, that gives us our angle A must be 10 degrees. Our next question is asking about angle BFC. Angle BFC this time, you can see it is on the inside of this circle. Okay, so since BFC is on the inside of this circle, we must be dealing with that other formula, that other theorem from the beginning that says we're going to take half the sum. So if we're taking half the sum, that means we're adding together the two arcs. We're adding together 35 plus 15 and dividing by 2. 50 cut in half is 25. And that's our answer for the angle BFC right there in the middle, 25-degree angle right there. All right. From here until the end of the notes, we're going to have a couple more theorems, a couple more rules, and we'll show you how they work and how they look in a couple of different diagrams, okay? So our first one is talking about segment lengths. This is talking about chords that intersect inside of a circle. Okay, so when I look at this one, I'm looking at this chord right here, and I'm looking at this chord right here. Okay, we've got a green chord and a red chord. And according to our formula over here, it says green part times green part equals red part times red part. Let's talk about what I mean by that. What I mean is that each of those chords has been split into two chunks. Okay? On the green chord, we've got one chunk is 6 right here, one chunk is X. Okay? So if we're talking about green part times green part, that is X times 6. If we're talking about red part times red part, that is 9 times 2. Okay, it's just talking about those two pieces that the chords have been split into. Pretty easy to follow, in my opinion. Okay, so what that does for us is it creates a pretty simple equation. X times 6 equals 18. 6x equals 18. Well, to get x by to solve for x, get x by itself, you just got to divide it out of there. We end up with x equals 3. Okay, so that is the rule for when chords cross each other inside of a circle. The two pieces, the product of the two pieces, are always equal. Go on to our next one. Our next one is talking about secants intersecting outside of a circle. Okay? So this one says outside times whole equals outside times whole. Let's talk about that. Okay, when we talk about outside times whole and outside times whole, what we're talking about is these pieces. Okay, you can see it's pretty self-explanatory that when we look at this red line segment right here, it's been, excuse me, let's use a green line segment right here. It's been split into two parts. Okay, the part outside of the circle over here is 2. The part inside is 18. So that means the whole entire thing would be 20. Okay, so when we talk about outside and whole, we're talking about the part that's outside the circle and then the two pieces added together. When we look at this other one, when we look at our other chord in this picture, the outside part is 6, but the whole part, or no, the outside part is x, but the whole part would be x plus 6. Okay, so here's what that looks like. The outside times the whole is 2 times 20. The outside times the whole is x, the piece outside, times x plus 6, those two chunks added together. So that creates a bit of a problem for us because if we're going to do this multiplication, on the right side here, we've actually got distribution. Okay, we have to distribute that x into the parentheses. And it ends up being a little bit complicated for us because we end up with an equation that looks like this. 40 equals x squared plus 6x. Y'all, that's rough stuff. Okay, so here's what we can do. What we're going to do first is we're going to subtract the 40 on both sides. Okay, we're going to go minus 40 and minus 40. And remember that on the right side of this equation, you can only combine like terms. So we end up with just minus 40 tacked on to the end of what we already had. This right here is an equation that you can solve in the calculator very easily. Okay, what you're going to do, let's see if I can write these steps down here. Okay, it ends up actually being pretty simple if you know how to do it in your calculator. Okay, let me write down the steps for you. Step 1, under y equals, type in this part. Okay, you're going to say that y1 equals x squared minus or plus 6x minus 40. Under y2, you're going to just put 0. Okay, so y1 is the right side of the equation, y2 is the left side of the equation. Okay, what you hit next, you're going to graph it. After you've graphed it, you're going to hit second, trace, 5. After you hit second trace 5, move the cursor as close as you can get it. Move the cursor as close to the intersection as you can get it. Okay, get as close to the intersection as you can get and hit enter 3 times. Okay, we'll have the example in class and you can ask me questions about it. After you've watched this video, you can ask me questions about it. I can show you specifically. Okay, that is what's going to give you your solution. Okay, it's going to end up giving you an x value and a y value, and the x value is the solution to that equation. It's x equals 4. Okay, there are also ways you can do this in Desmos, ways you can do this using a bunch of different programs. Okay, if you just ask me questions about it, I can point you in the right direction. I could also point you in the direction of the methods you learn to solve equations like this in Algebra 1, like the quadratic formula. I could point you in the direction of factoring, which you're going to do a lot of in Algebra 2. Okay? A bunch of different ways to solve that equation. This is just a quick and easy one in the calculator. Okay? If you have any questions about that, please just let me know. Go on now to our last one. Our last rule says that when you have a tangent and secant that intersect outside of a circle, tangent times tangent, okay, the length of that tangent piece, tangent times tangent equals outside times hole, okay? Don't lose track of what your outside and hole are, okay? This right here is the outside, okay? The outside is 4. This right here, the whole entire thing, the hole is 9, okay? Don't lose track of that. So tangent times tangent in this example, just x times x. Outside times hole becomes 4 times 9. So x squared equals 36. Not the hardest equation we've ever solved, is it? Because if you just take the square root, and we can figure out that x equals 6. Okay, that's all we're going to have for this section. That is the end of our topic 12 notes. We'll be coming up pretty soon on a test review and a test. So be ready for that, and y'all have a good one.